Hey guys, today we're going to see the distribute candies problem, and this problem number 575 in LeetCode. So given an integer array with even length where different numbers in this array represent different kinds of candies, each number means one candy of the corresponding kind. So every number means a different kind of candy. Okay, so you need to distribute these candies equally in number to brother and sister. So two parties, brother and sister, you have to equally distribute it to them. So return the maximum number of kinds of candies in the sister could gain. So let's look at this example one. So candies, you have 1, 1, 2, 2, 3, 3. And as you can see, for candies of type 1 there are 2, candies of type 2 are 2, and candies of type 3 are 3. So they are equal in number, so which means you can evenly distribute it to the brother and the sister. So therefore the output is 3. So you can distribute 3 to the brother and you can distribute 3 to the sister, and there are only 3 different kinds of candies the sister could gain. Let's look at example 2. So input candies equal to 1, 1, 2, 3, which means there are 3 different kinds of candies and we have got 2 people. So which means you have to give 2 different kinds of candies to the sister. That's because we have to maximize the number of kinds of candies given to her, right? So 1 and 1 the brother will get, and 2 and 3, which are 2 different types, the sister will get. So the different kinds of candies the sister gets is actually 2. So if you observe, given an array and given 2 parties, right, if there are some quantity, the maximum way you can equally distribute that quantity is going to be n by 2. So here, whenever there is a unique quantity, unique kind, we have to basically give the sister that count. So she is going to get the maximum number of candies. So for example, let's take this last example just because it is small. So we take 1, 1, 2, and 3. Length of this array is going to be 4, right? Length of this array is 4, which means 4 by 2, and the maximum she can get only 2 candies, right? So how do we know that she is going to get 2 candies. Using this fact, how can we identify how many different types of candies she is getting? So basically what we can do is distinct type of candies we can get by putting it in a hash set. Right, in a hash set you can only put in distinct elements of a set. So if you put these elements of this array in the hash set, you're going to get 1, 2, and 3. Okay, and n by 2 is going to be 2. And when you calculate the minimum of this is going to give us, so minimum of the hash set size, which is going to be 3, and n by 2, 4 divided by 2, this is going to give us the number of distinct quantities of candies that she is going to get, which is again 2. Okay, so in the case of first example, let's take the first example. So you've got 1, 1, 2, 2, 3, and 3. So we've got 3 different kinds of candies. So in the hash set you will have 1, 2, 3, and n by 2 it's going to be 3. So minimum of these 2 is going to be again minimum of the hash set, the distinct number of candies, and the total count divided by 2. So which is 6 divided by 2, which is 3. So the number of different kinds of candies that you can get is 3. Okay, so I hope the explanation is clear. So let's code this program. So I'm going to just have a null check. So I'm just going to say candies equal to null or candies dot length. This is equal to 0, then you cannot distribute anything, so it's going to be 0. So if not, we're going to have a hash set of integer equals new hash set of integer, and for every element and candies. I can just say just candy for every candy and candies. Put it in the set.add of candy. So now we'll have distinct elements in this set. So we have to return math.min of set.size, comma, candies.length by 2. Okay. Oh, there is a spelling mistake. It's accepted and submitted. And yeah, it's a successful submission. So, and if you see, the space complexity is of n because we're using a hash set, right? And when you consider the time complexity, we're just adding it to the hash set and taking the minimum, right? So at the max, it's O of n because we're iterating over the candies, we're trying to add distinct elements in the hash set. So space and time complexity both are O of n. Okay, I hope you like it. Bye guys.